Hello everyone! In this video we're going to be talking about strings. Now strings, remember, are a special type of character array. And to manipulate strings, C provides us with 4 basic string functions, which is what we'll spend our time talking about today. So we're already familiar with how to declare arrays. We know that they have a data type, a name, and a size in these square brackets. So if we want to create a string is an array of characters. So we're going to make our data type character, our name, whatever we'd like, and our size, however long we'd like our string to be. Now, when I first told you about strings in our files chapter, I said this would create a string with room for 19 characters. And now that we've been dealing with arrays, we know that the size is usually the full size of the array. But this one, when we're making a string is a special type of character array, we have to save room for what's called the null character. So yes, we're going to have 20 characters, but we can only choose 19 of them. The last one has to be the null character. And this is specific to strings in the C programming language. They're called null character terminated, which means this character, this escape sequence, goes at the end of every string to mark the end of the string. So when we're using strings, all of them secretly have this null character at the end. We never print it out so that the user never sees it, but it's there marking the end of the string. So if we want to initialize our string with some specific values, we can use our array shortcut where we specify each individual character and ending with the null character. So in order for it to be a string, it has to end with this character. When we use some of our other string mechanisms, for example, if we were to use this to initialize a string, the programming language automatically puts the null character in there. And that's because these double quotes indicate a string, so it knows that since this should be a string, there should be a null character at the end. The same thing happens when we're using the string percent code %s. If we read in a string, we're going to read in all of the letters that the user enters, plus adding in a null character at the end to mark it as a string. And that's going to be the key to all of our functions, knowing where the string ends. The string ends at the null character. So we're going to start looking at 4 main string functions. Since strings are stored in arrays, we can't do some of the relational operators that we're used to doing with numerical inputs. So we're going to see how the string library gets around that. So we're going to include in our programs, the string library includes string.h, and that'll give us access to the functions that we're going to talk about today. Now the first one is string copy. And as you might imagine, it's capable of copying a string from one location to another. So what I have here is the 3 different prototypes that are commonly accepted for copy. The first one shows our character arrays as pointers. So remember, arrays are already references, so the name of the array is automatically a pointer. So this is an acceptable version of our prototype. This says we're taking in string 1 and string 2. And what copy does is it takes the contents of string 2 and puts it into string 1. You can see also in the prototypes this keyword constant. That means the function is not capable of modifying string 2. String 2 is going to be constant. But if you're not comfortable with the pointer representation, you can also do the same thing with arrays. So let's look at this one on the bottom. This is string copy. The name is strcpy for string copy. It takes in 2 parameters, 2 strings, string 1 and string 2. The second one is constant, so it can't be changed. And what we do is we copy string 2 into string 1. And since they're references, we don't need to return the string, so we can have a void return type. So let's go ahead and use this particular function. We're going to add our string library to our program. And the whole point of this program is just going to be to demonstrate these string functions. So we're going to need to create a string, and then we can call string copy to put values into our string. Our string is word 1. And if we want it to say hello, for example, we can copy the string hello into word 1. So this is our variable name for the string. This is a string literal, so it's identified by these double quotation marks. That forms a string. Then we can print out word 1 using the %s string percent code, and we should see the contents of our string. Hello! Okay, so string copy, again, strcpy, copies the second parameter into the first parameter. We'll strictly overwrite the first parameter with this second string. Our next function is string length, and what string length does is it calculates the length of a string. So it does have a return type. It returns an integer, which is the number of characters in the string. It's called string length, strlen for string length, and it only takes in one parameter, a constant string. So we're not going to make any changes to s in this function. We're just going to count how many characters are in there. So before we use string length, I want to really emphasize how this works. And it works based on that null character termination that I was telling you about earlier. So if we wanted to write our own string length function, what we would do is we would try to navigate the string. We will count each character until we get to the end, and the end is marked by the null character. So we'll navigate through our string just like we would any other array, starting at the beginning, so starting at I equal to 0. And as long as we've not gotten to the null character yet, then we should keep going. And we're going to increment length. So we can print out the length of our string so the length of word 1 is length. So now we're seeing our string from earlier, the one that we copied hello into word 1. Then we counted all of the characters in word 1. It says the length of hello is 5. So those are the number of characters in our word. It doesn't count the null character, it just counts everything before that. So instead of this, we can just use our function, string length, which calculates the same thing, using the same idea, counts all of the characters before the null character, and returns that integer. So there are 5 characters in the word hello. Now our next function is a little bit more complicated. Since strings are an array, we can't use our relational operators on a set of values. We can only use them on individual elements. So in order to do a string comparison, we're going to need a special function. So this is going to be string compare, but we need to do some background information. The comparisons that string compare is going to make are called lexicographical. These comparisons are going to be lexicographical comparisons. And what that means is that these comparisons are going to be based on the ASCII values. Now, ASCII is the encoding that C uses for all of its characters, and it's based on an integer value. So each character that we print using %C has a related integer value from 0 to 255. So even though I is an integer, if we print it out using %C, then we're going to see the character that corresponds to that integer. So ASCII encodes all of the letters, all of the numbers, all of the punctuation marks, and several other symbols that are not common. So I'm going to go ahead and print all of them out so that we can see all of the ASCII characters that we have access to. And you can see that some of them are kind of weird. So the first one is the null character. We don't see anything there. One of them's a backspace. One of them's a tab. One of them's an enter. So all of the characters that we can normally print out are all encoded with ASCII. So that includes digits. We have character forms of all of our numerical digits. And then our letters. So uppercase letters are 65 to 90, and the lowercase letters are 97 to 122. And so the reason that's important to us are these lexicographical comparisons, because they're based on this numerical value. So uppercase letters, because they have smaller numbers, are always perceived as coming before lowercase letters. So uppercase letters come first because they have smaller numbers than all of the lowercase letters. But if the casing, if all of the letters in the two strings that we're comparing are all uppercase or all lowercase or have the same matching case, then it's just an alphabetical comparison. So what we're going to do in a lexicographical comparison is we're going to compare corresponding characters. So we'll compare the first letter of the first string to the first letter of the second string. And then we'll compare the second letter of the first string to the second letter of the second string. We're going to keep going until one of the strings ends or the characters are different. So if that happens on the very first character, we can quit early. And that difference is usually calculated as the difference between the two ASCII values. So here's some examples so that we can kind of work through that. We're going to compare across a row. So dog to cat, dog with an uppercase G to cat, baseball to basketball, and baseball to base. So what we do is we look at the first letter of each string, and we'll compare them. So they're different, so we're going to get our answer right after looking at the first character. C comes before D. So in a lexicographical comparison, we would say cat comes before dog. Okay, that's a nice easy one. Let's look at the second one. This one has an uppercase D and a lowercase c. So remember, uppercase characters have a lower ASCII value than lowercase characters. So we always perceive uppercase as coming first. So in this case, we would say dog with an uppercase D comes before cat, where it's all lowercase. So let's look at some strings that have some commonalities. This is baseball and basketball. We're going to compare the first character of each string, and they're both B, so we'll move on to the second character. So then we're going to compare the second characters of both strings, and they're both A's. So we'll move on to the next one. The third character of each string is an S, so they're the same. So our comparison is going to be based on this E and this K. Now since E comes before K, a lexicographical comparison would say that baseball comes before basketball. This last example has a prefix in it. So we're going to compare B to B, A to A, S to S, and E to E. Now our second word ends. So when we go to compare the character in the next element, this one is B, and this one is the null character. A null character has an ASCII value of 0, so it always comes first. So prefixes come before the rest of the word. So we would say base comes before baseball. So after we've done the comparison, we need some indicator of what the result was. So the actual return type for a comparison function is an integer with these representative answers. If string compare returns as 0, then they're the same string. This means we got all the way to the null character for both strings and didn't find any differences. If we get a negative value, that means our first parameter, our first string, this side, comes first. And if we get a positive value, that means our second parameter, the second string, or this side, comes first lexicographically. So this is our string compare function, returns an integer. It's called with the name string compare, strcmp for compare. Takes in two strings, both of which are constant, which remember that just indicates that compare cannot make changes to them. So two strings, string 1 and string 2. And it will compare them and return an integer value. 0, the strings are the same. Negative, S1 comes first lexicographically. Positive, S2 comes first lexicographically. So now we're going to take this and use it. We're going to add a second string so we have something to compare to. And we're going to have the user enter that string for us. Which we'll scan in using the %s %code. This tells the compiler it's a string and that it needs to add in the null character to the end of the user's input. And we're going to store that in word2. So remember, the name of an array is automatically a reference. So we're not putting the ampersand in front of this because we don't want to dereference a reference. So we're going to call string compare on our two strings, that's word 1 and word 2. And remember, if we get a negative value, that means the first parameter, in this case word 1, comes first. We'll do the comparison and then print the results. If we get a positive result, that means the second parameter comes first. So word 2 before word 1, the second parameter. And if it's not positive and it's not negative, it must be 0, which means both strings are the same. And it doesn't matter which one we print out because they're the same string. So we're going to allow the user to enter some different string values so that we can see how the comparison works. We know that word 1 is hello. So if we put something that has a lowercase letter as the first letter, then the comparison will be alphabetical. So A comes before H, so apple comes before hello. But if we put in something with an uppercase character as the first letter, then that one's always going to come first because capital letters come before lowercase letters. And of course, if we put in the same string, then it'll recognize that both strings are the same. Both strings are hello. Okay. Our final function is called string concatenate. So when we're concatenating, we're adding something onto the end of something else. So string concatenate, S-T-R-C-A-T for concatenate, is going to add this second parameter, S2, onto the end of S1. So whatever they put here is going to be added onto the end of this one, and it will strictly modify S1. So S1 will be different. It will have the previous contents of S1 with S2 then following it. So let's start a new file. Where we ask the user for their first and last name, and then we're going to concatenate them together to say what their full name is. We'll still need our standard input and output library, and we're also going to need our string library now. We're going to create our two strings, first name and last name, and full name. And here's the problem with concatenate. String concatenate's not going to double check the size of the strings to make sure there's enough room. So instead, it's our job as the programmer to make sure that there's enough room in our string to hold both of the things that we're trying to put there. So I'm going to make full name double size of the original names, and I've added an extra character slot because I'm going to put a space between the two. Okay, then we're ready to start putting them together. We're going to get the first name from the user and the last name, and we're going to start putting them into full name. So the first thing we're going to do is copy into full the first name. Then we're going to use our new function, the string concatenate function, to add on to full a space and then the last name. Sorry, this is F name for first name. So we start with full having a copy of the first name. Then we add a space onto the end of it. Then we add the last name onto the end of that. So full should now have the full name. So we can print out full. We can also print out how many characters it has. That'll be the length of the full name minus 1 for the extra space that we added to it. So let's test this program out. If we put in my first name and my last name, it will tell me my full name is Sarah Angel, which is true, and that it has 11 characters in it, and 5 plus 6 is 11, so it appears to be working correctly. So those are our 4 basic string functions: string concatenate, string copy, string length, and string compare. So let's look at a practice program. This is something that you probably do quite frequently because it's in all of our modern login systems. It's the task of password verification. we're going to write a really short program that asks the user to enter their password, and then we're going to ask them to enter the password again. And our job is just to make sure that they're exactly the same. Let's go ahead and try this practice program, pause the video while you do that, and then come back and watch my solution. Okay, so we're going to start with two strings. The first version of the password and the second version of the password. And they should probably be the same length because we're expecting both passwords to be the same length. We're going to prompt the user for both. Make sure we're using strings, so use the correct percent code, %s for strings. Put it in one of the passwords. And then to verify, I'll have them enter it again or re-enter. And this one has to go inside the other password, so password 2. Now we need to check to see if they match. So in order to check to see if they're the same, we're going to need to do a comparison. So we're going to use string compare. And in this case, we're only concerned if string compare gives us the value that indicates they're exactly the same. So we only care if the comparison of the two is equal to 0. So if they're exactly the same, then they match, and we can print out passwords match. And in all other cases, regardless of which one comes first, they don't match, and we'll print out these passwords do not match. Okay, so let's try this out. Say, what is your password? And of course, when you're testing this program, you shouldn't enter your actual password just in case anybody else is looking. The key to a lexicographical comparison is that it's automatically case sensitive. So if we enter something with the wrong casing, you see this one has a lowercase s, this one has an uppercase s, they don't match. So they have to be exactly the same in order for them to work. But when they do match, the program correctly identifies that the passwords match. So our password can be verified, and our string compare function takes care of that for us. In our next video, we'll look at another library that has some cool functions that interact with strings, and we'll do some more string examples so that we can make sure we really understand these string functions. I'll see you there.